This was the problem we considered in the last class. F of x equal to minus pi if minus pi less than x less than 0 and x if 0 less than x less than pi. Right. We have discussed how to find a naught and a n. So I'll just write a naught. We have determined to be a naught equal to minus pi by 2 and a n minus 1 by n pi n square times 1 minus of minus 1 power n. Or we might have written this as a n equal to 1 by pi n square minus 1 power n minus 1. I don't know exactly which term I have written in the last class. Now we need to determine Bn. Let us proceed for Bn. Point number 3, Bn. So what is the formula for Bn? Bn equal to 1 by pi integral minus pi to plus pi f of x sin nx dx. Bn equal to 1 by pi integral minus pi to plus pi f of x sin nx dx. So this is the formula to find Bn. So first I have written the formula. Then see here the function is defined in two subintervals. When x lies between minus pi and 0, it has some value, and when x changes its interval, function takes a different value. So depending on the subintervals, we have to split this integral into two. So first one is from minus pi to 0 and second integral is from 0 to plus pi. So integral minus pi to 0 f of x sin nx dx. But when x lies between minus pi and 0, f of x is minus pi. I have to write the value of f of x here. So minus pi into sin nx dx. This is about the first interval. So I have to write the value of f of x in the corresponding interval. So plus here integral. So now we have to look into the second interval 0 to pi. So when x lies between 0 and pi, the value of f of x is x. So it is x into sin nx dx. Right. So now we need to integrate these. So I'll write from here. That implies bn equal to 1 by pi 1 by pi. Here minus pi is a constant that you can take outside. Minus pi into integral of sin nx minus cos nx by n. This should be evaluated between minus pi and 0. This integral should be determined between the limits minus pi and 0. Plus, now here we have product of two terms. X into sin nx we have. X being an algebraic function, this we need to consider as first function, and sin nx will be obviously second function. So first we need to identify first and second function. Then you have to apply Bernoulli's rule of integration. So how we can apply Bernoulli's rule of integration? So you have to keep the first function x into integrate the second one minus cos nx by n. So here we have plus sign. So next we need to write minus sign. So minus derivative of first function, that is 1 into integral of minus cos nx by n. This is just like 1 by n into integral of minus cos nx. So integral of minus cos nx will be minus sin nx. We have already one n in the denominator, and differentiating nx here, I'll get one more n, that leads to n square. Now, if you continue, this should be obviously plus. Here we have minus sign, we need to write alternating sign, so I had to write plus here. Derivative of 1, that is 0. So this term is not necessary, you can end up here only. And these two terms should be evaluated between 0 and pi. These two terms should be evaluated between 0 and pi. So, okay. And now, let us close this bracket. Now, let us apply limits. Bn equal to 1 by pi times Bn equal to 1 by pi times. Here, let us take constant term outside. Minus into minus, you have minus into minus. So minus into minus will be plus. So plus pi by n times cos nx. Plus pi by n times cos nx, which should be evaluated between minus pi and 0. Pi by n into cos nx, that should be evaluated between minus pi and 0. And coming to this, minus 1 by n will be a constant term. Minus 1 by n into x into cos nx. Minus 1 by n times x into cos nx, which should be evaluated between 0 and pi. Minus into minus plus 1 by n square into sin nx. Okay, here you can observe that applying upper limit, you get sin n pi, which is 0, and again applying lower limit, sin 0, which is again 0. So you can write 0 directly. So this term is not necessary. You can just write 0, or you can end up here only, the last term. Yes. Now, let us apply limits carefully. Let us apply limits carefully. Bn equal to 1 by pi by n times applying upper limit. See, applying upper limit, you get cos 0. Cos 0. Okay, first I'll write cos 0. Minus. Applying lower limit, see, actually we get cos n of minus pi. But we know cos minus theta is equal to cos theta. Cos is an even function. So cos n of minus pi, that is cos minus n pi, will be cos n pi only. Minus 1 by n times, applying upper limit, you get pi cos n pi. Pi cos n pi. Minus applying lower limit, see, you can get 0 into cos 0, that is 0. So Bn equal to 1 by pi times pi by n times cos 0 is 1, right? 1 minus cos n pi minus, see, minus pi by n minus pi by n into cos n pi minus pi by n into cos n pi. Now, if you take pi by n outside, okay, let us write one more term. Let us split this, then take common factor. Pi times, see, it is pi by n minus pi by n cos n pi, again minus pi by n cos n pi. Right. Now, these two terms will add up. Get Bn equal to 1 by pi by n. So we can take pi by n outside. So this pi by n times, see, I'll write bracket here, 1 minus, see, pi by n I have taken outside, you get minus cos n pi minus cos n pi, that is minus 2 cos n pi, minus 2 cos n pi. Now this pi cancels with this, and we know that the value of cos n pi is minus 1 power n. So it becomes Bn equal to 1 minus 2 into minus 1 power n divided by n. Bn equal to 1 minus 2 into minus 1 power n by n. Now we have determined a naught, an and bn. Substituting for a naught, an and bn in equation 1. So equation 1 we have written in the beginning of the solution. Substituting a naught, an and bn in equation 1, we get, so on substitution I'll get f of x equal to a naught, what is a naught, minus pi by 2, but I want actually a naught by 2 here, right? So it will be minus pi by 4 plus summation n ranging from 1 to infinity, an value I have to write, that is minus 1 by pi n square. Okay, I'll write a second, 1 by pi n square times minus 1 power n minus 1, minus 1 power n minus 1, that is an into cos nx plus summation n then from 1 to infinity bn, that is 1 minus 2 into minus 1 power n divided by n into sin nx, right? So this is f of x on substitution. And now we need to deduce an expression from this one, so you have to simplify this expression. From that we can deduce the required expression. Now I can rewrite this. Okay, before going to that, first determine this one. We have minus 1 power n minus 1 equal to minus 1 power n minus 1 equal to, okay, yeah, I have to consider two cases, n odd and n even. When n is odd, minus 1 power n is minus 1. So minus 1 minus 1 you get minus 2. So when n is odd, minus 1 power n minus 1 is minus 2. When n is even, minus 1 power n minus 1 will be 1 minus 1, that will be 0. Similarly, this, let us write what is the value of this. We don't know exactly whether we need the value of this one or not. Let us determine. Nothing wrong determining that. So again I have to consider two cases, n even, n odd. So if n odd, it will be minus 1, minus 1 power n will be equal to minus 1. So 1 minus 2 into minus 1, 1 minus 2 into minus 1, that will be 1 plus 2, it will be 3. And when n even, minus 1 power n will be plus 1, 1 minus 2 it will be, so it is minus 1. Now this expression takes the form, this I'll retain as it is, 1 minus 2 into minus 1 power n ಅಂತಾನೆ ಬರ್ಕೋತೀನಿ. ಇದನ್ನು ಮಾತ್ರ n even n odd ಅಂತ ಚೇಂಜ್ ಮಾಡ್ಕೊಂಡು ಬರ್ಕೋತೀನಿ. Thus we have Thus we have f of x equal to minus pi by 4 plus, here I'll take n only odd values, n equal to 1, 3, 5 and so on. See, when n is odd, minus 1 power n minus 1 will be minus 2. So it is minus 2 divided by pi n square times cos nx plus, see here, if you consider n even and n odd, then you have to write two summations. One is for n odd and another one is for n even. So for that, to make the expression simpler, I will just retain that term as it is. Summation n ranging from 1 to infinity 1 minus 2 into minus 1 power n divided by n into sin nx. Call this as equation 2. Now from this we need to deduce the expression. What is that expression? That expression is, I'll write here, pi square by 8 equal to 1 by 1 square plus 1 by 3 square plus 1 by 5 square and so on. Can you guess which value of x is suitable to get this expression pi square by 8 from the equation 2? Can anybody guess the value of x? Which value we can take? You just guess the value of x. Let us check whether it will be suitable or not. Any reply from your side? Try to guess the value of x so that we can deduce the required expression from equation 2. So you have to get only odd terms, 1 by 1 square plus 1 by 3 square plus 1 by 5 square you have. So you have to get only odd values of n. So even values of n you should not get. In that sense, I had to choose the value of x. Can anybody guess? You can write in chat box too. You have to guess at least some value. Let us check it whether it is suitable to get that expression or not. No reply? So, see here we have only odd terms. Here also I have n equal to 1, 3, 5. So only odd values of n I have. So I had to choose x, that I had to retain this term, and this should be vanished. So for that I had to choose value of x so that cos nx is non-zero and sin nx is 0. If you look
Sir,
into
one.
the interval, ಹೇಳಪ್ಪ.
Sir, one thing.
In x value ಏನು ತಗೋಬಹುದು?
Sir, one.
I had to choose value of x within this interval. I think that I have
Okay, sir.
explained in last class. First, usually we take end values, and if that is not working, then we go for midpoints, 0 or pi by 2 or minus pi by 2 and so on. So this is working when the function is continuous. If the function is not continuous, that we say discontinuous function, then that series, this will converge to, series converges to f of x plus f of x minus by 2. X plus means this is called right hand limit and left hand limit. This one is f of x plus, that is right hand limit. This is right hand limit and this one is left hand limit. Okay. Now here, if I take, as I said here, if I take first end values, x equal to pi or minus pi. I check one. X equal to plus pi or minus pi. If you take this, then here we'll be getting cos n pi, that is minus 1 power n. But this leads to alternating signs. That leads to alternating signs. But look into this expression. Here we don't have alternating signs. So x equal to pi or minus pi is not suitable. So next option is x equal to 0. If I take x equal to 0, cos 0 will be 1. If we take x equal to 0, cos 0 will be 1 and sin 0 will be 0. So that this term, the second term of f of x is retained and third term is vanished. That is removed or it is vanished. So I hope x equal to 0 is suitable. Let x equal to 0, which is a point of discontinuity. Which is a point of discontinuity. Why this is a point of discontinuity? Meaning of that is function is not continuous at that point. See, if you look into the graph of the function, I have written the graph in the last class also. When x lies between minus pi and 0, it will be like this. Between minus pi and 0. In that interval, the function is like this. When x lies between 0 and pi, so the function is not continuous at x equal to 0. At all the points except at 0, the function is continuous. Hence, the series hence the series converges to f of 0 plus f of 0 minus by 2. f of 0 plus means from positive side I have to take f of 0. This is f of 0 plus. From this side I have to look into the function. This is f of 0 minus. As limit approaches from left side and right side, that I have to compute separately. That is actually equal to, see, f of 0 plus. As you move from this direction, as you move from this direction, as x tends to 0, f of x tends to 0. Okay, let us write one more term. F of 0 plus. If you look into look in this direction, look from this direction, then function will be x. Plus, if you look from this direction, function is minus pi by 2. This you have to take as x tends to 0. This will be 0 minus pi by 2. So minus pi by 2. Thus, equation 2 implies left hand side is minus pi by 2. Left hand side is minus pi by 2. See, you cannot take if x equal to 0 directly. That actually gives you some other value to which the series is not converging. I have to take f of 0 plus f of 0 minus by 2. F of 0 plus means you have to take limit as x tends to 0 from this direction, from positive side. F of 0 minus, you have to take limit as x tends to 0 from negative side. Average of that will be the point of convergence. So minus pi by 2 equal to minus pi by 4. Here let us take this constant term outside. Minus 2 by pi summation n ranging from, okay, n is 3, 1, 3, 5 and so on, right? 1 by n square into cos nx, that is cos 0. We have cos 0 equal to 1. Now take this minus pi by 4 to the right hand side. Minus pi by 2 minus pi by 2 plus pi by 4 equal to minus 2 by pi times summation 1 by n square. N ranges from 1, 3, 5 and so on up to infinity. So minus pi by 2 plus pi by 4 is minus pi by 4 equal to minus 2 by pi into, if you expand this, you get 1 by 1 square plus 1 by 3 square plus 1 by 5 square and so on. So minus into minus it cancel. So cross multiplying this, pi square by 8 equal to 1 by 1 square plus 1 by 3 square plus 1 by 5 square and so on, right? That is the required one. So with this, the solution of the problem is completed. So still now we have discussed how to find the Fourier series expansion of the given function. See, generally you will be given with f of x defined on f of x, obviously a periodic function, because the interval on which the function is defined is restricted to minus pi to pi or 0 to 2 pi, which is interval of length 2 pi. To find the Fourier series expansion, first step we have to consider the given function. First step is consider the given function and the interval. So I have to collect the given data. That is very much important. That is the important step actually. Second step, second step, Write down the general Fourier series expansion. That is f of x equal to a naught by 2 plus summation a n cos n x plus summation b n sin n x, and then from 1 to infinity and then from 1 to infinity. Now, after writing this third step, I have to determine a naught, a n and b n. I have to determine a naught, a n and b n. We have formula for a naught, that is 1 by pi. I had to write endpoints of this interval, whether minus pi to pi or 0 to 2 pi. Looking into the given problem, I had to write this interval. I had to write the limits looking into this interval. So if you are given a function on minus pi comma pi, then it will be 1 by pi times interval minus pi to plus pi f of x dx, and a n will be 1 by pi interval minus pi to plus pi f of x cos n x dx, and bn 1 by pi interval minus pi to plus pi f of x sin n x dx. I had to determine a naught, a n and b n. I mean, yes, I had to call this as equation 1. Fourth step, substitute for a naught, a n and b n in equation 1. Okay, if you need to deduce an expression, then you have to go for fifth step. Choose suitable value of x and simplify. So these are the steps to be followed to find the Fourier series expansion from the, I mean, of the given function. Okay, with this, let us wind up discussion on